Welcome to my channel. We are continuing our sequence on integration, and the playlist with all of the videos on this topic is in the description down below. You can check that out, and we are continuing with our integral. So we have a little bit of a similar structure to what we had in the last video of ours. This time it's x squared instead of 1 and arctangent of x. We'll use integration by parts, and as we did in the last video, I'll use arctangent of x as the function we will differentiate later on, because it's not that easy to find an antiderivative of arctangent x, while the antiderivative of x squared or any polynomial is trivial. And in the background we know that the derivative of arctangent x will be 1 over 1 plus x squared, so we'll just deal with this function later on. Okay, a brief note on what we'll obtain here is we want to have a form fg minus fg prime. Note that I use different notation all the time. Sometimes I use fg prime, sometimes I use f prime g, but the main idea is that in the end we have one function which is differentiated and the other function. We first multiply two functions. It means we find an antiderivative of the differentiated function, and we subtract the integral of that original function multiplied by the derivative of the other function. The idea is simple. Now let's proceed with our problem. So first we need to find an f. It's an antiderivative of x squared, which is x cubed over 3, multiplied by arctangent of x minus, we already have antiderivative of x squared, so let's just rewrite that, multiplied by the derivative of our g, derivative of arctangent, which is 1 over 1 plus x squared, and dx. Okay, we have x cubed arctangent of x over 3 minus 1/3 integral of x squared dx over, here we should write cube, right? Because we just repeated this here. Okay, so we have x cubed dx over 1 plus x squared. Okay, now let's take our time and think on how we can evaluate this integral. Let's evaluate it as a remark, and to not lose the structure, let's write that it's equal to some star, and let's evaluate the following integral. Let's write it here, x cubed dx over 1 plus x squared. How should we do this? Okay, I'll record a video on how we should deal with the rational functions and their integrals, but for now, because the degree of numerator is bigger than the degree of denominator, we should first divide it. We do this by long division. Let's write it here. X cubed we divide by 1 plus x squared. First, what we have is x, so that x cubed here disappears. Okay, it's x plus x cubed. When we subtract, we get minus x. Okay, now it means that minus x is our remainder, and we get the integral of, okay, this means that x cubed over 1 plus x squared is equal to x plus remainder minus x over 1 plus x squared. I hope there is no problem in long division, so I won't get into details of this process. Okay, our integral is equal to x minus x over 1 plus x squared dx. We can write this as x dx minus x dx over 1 plus x squared. For the sake of convenience, I'll do the following. This is equal to first integral of x dx, which is x squared over 2, minus the integral of x over 1 plus x squared. Last time we did it, it's 1 over 2. We can do this by the method of substitution. If you will have any problems here, please go to the previous video. You can access it in the playlist. It's the 7th video of the sequence. There I computed it in details, this integral. It's 1 over 2 as far as I remember, ln of 1 plus x squared. Let's just quickly check it. If we differentiate this with respect to x, we get 1 over 1 plus x squared multiplied by derivative of 1 plus x squared, which is 2x. And since we have 1 over 2 here, 2 cancels, so it's x over 1 plus x squared. Everything is right. And let's not forget our constant c. Okay, this will be our remark. We continue with our star. The star is equal to x cubed arctangent of x over 3, arctangent of x over 3, minus 1 over 3 times the integral that we found here. It's x squared over 2 minus 1 over 2 ln 1 plus x squared and plus some constant c. Let's write the final answer, which is x cubed arctangent of x over 3 minus x squared over 6 plus 1 over 6 ln 1 plus x squared plus some constant c. Let's write it c hat and here c hat, so that in the end we get just some other constant c. Okay, this is our final answer. Right. If you have any questions, feel free to write them in the comment section below. I'll try to answer all of them. See you on the next videos.